The most hard to understand device that I have here is a transformer. Transformers are, there are a lot of examples of transformers. They show up in electricity all the time, electrical circuits, but probably what you're most familiar with is your cell phone charger. Cell phone chargers are transformers. One side plugs into the wall, and then the other side has a wire that then plugs into your cell phone, because you wouldn't want to plug your cell phone directly into the wall. It literally consists of two coils. I'm going to remove that for a moment so that you can see the two coils here. Okay, so the this coil here, the input coil is the primary coil. The output coil is the secondary coil. Now technically these are two separate circuits. They are not connected to each other. You can see I can slide these coils up past each other. There is no wire connecting the two coils together. They're completely separate. And so technically it's two circuits. However, as I've warned you, when you see a coil, you know that magnetism is going to play a role, and that is certainly going to be the case here. And so this is just an iron core that's been specifically built to ensure that we get a nice strong magnetic field in here. So what's that magnetic field going to do for us? By the way, some transformers do have the coils side by side. A lot of transformers have one coil inside the other coil. That in some ways is actually even a more efficient way, but you can't really see that kind of thing. So I'm working with this transformer here. So here's an example of what I would do. I'm going to bring in all these batteries here. So it's a little collection of batteries. And if I hook them up to here, let's see, you might see the spark. You see the spark where I'm connecting it. So clearly I have voltage here creating a current. Current's going through this coil. Okay, so basically this is an electromagnet. So right now I have a magnet. So right here. And the question is, so what? Well, this magnet creates a magnetic field that then gets contained in this iron core. So this coil can now be affected by that magnetic field. So I'm going to disconnect this for a sec. Let's bring something in and plug it in to the secondary coil, the output coil. So what I have here is a little light bulb, okay, and I'm just going to move it out here a little bit. So I have this light bulb hooked into the secondary coil. All right, and so what I'm going to do is when I connect this like that, okay, so now I have my current going through here. I have a magnetic field here. Now the magnetic field is now, this coil is now sitting in the magnetic field. Nothing is happening. The light bulb doesn't light up. Why is nothing happening? Because just like with the pickup coil, it isn't enough to put a magnet inside the coil to induce current. I need to have the magnet moving or the magnetic field changing in some way. So how can I make this magnetic field change? Well, one of the ways I can make it change is to turn it on and off and on and off and on and off. So I'm going to do that by basically tapping either side of this conductor here, and you'll see a little flurry of sparks moving here. So I'm going to do that, and I'm now changing the magnetic field. And as I change this magnetic field in the primary coil, I'm getting now a current. I'm inducing a current in the secondary coil. Notice that it's also a changing current as well. But there I am. I'm lighting up the light bulb. There is no wire connecting these batteries to that light bulb. This is happening via a magnetic field.